Dear researchers, this video is about use of genetic algorithms like Wales optimization, particle swarm optimization, many other algorithms, genetic optimization algorithm. How to use these algorithms in edge, fog or cloud computing IoT networks. So this video talks about genetic algorithms and their usability in edge, fog and cloud IoT networks. To explain this, we are considering smart home security devices. We are considering smart home security device, smart home security system for explanation. So we have an application by name Smart Home Security System. So this application has some usabilities like that. We're simulating using ifogsim simulator, but I'm trying to explain the general scenario how this is. There are multiple cameras, Wi-Fi based web cameras, which are all deployed on a house at multiple locations and these cameras are smart cameras. They capture the videos, live videos, and upload to the Wi-Fi router which is placed in a house, and that Wi-Fi router will again connect it to the output devices like LCD display, where people can see the live the movements of the various objects in the house. And here the thing is, this fog resources, what I can say, Wi-Fi router will also identify the objects and detects any threats, possible threats, and after detecting the threats, it is also going to generate alerts. These alerts will be sent to the particular people, means based on the category of the alert. If it is a fire alarm, then it should go to the fire branch. If it is something crime or some thief is entered the house and detected that somebody unauthorized entry, immediately police has to be informed. So like this, based on the threat, it should be notified to particular people as well as to the house owner. And again, this edge devices, what we talk as smart cameras, are uploading the videos to the Wi-Fi router. It is in the house only. Similarly, multiple houses in the city are all monitored, and as well as to support monitoring from other places, means remote monitoring. To enable remote monitoring, all these routers are again connected to proxy. Through proxy they are again connected to cloud. So cloud is used to storage purpose, storing the captured videos for long term usage. So in future anybody wants to review what happens in the past, and so that data center is going to be make used for storing the videos on cloud, all the captured videos. So this is the scenario. I think you understood the total scenario how smart home security system based on IoT networks works. So here you will notice the four type of devices. One device is like smart cameras. They are also having small capability, and we call them as a edge devices. See, you could see in the diagram. See, sensor means a camera, smart camera. It captures the videos. After capturing the videos, it uploads to the gateway, and gateway is like a fog resources, means a mediator layer. It is also having computing capacity little better than the smart camera. It can process, it can identify the means any what job it does we will decide later, but it is also having computation capacity, and it is directly connected to the alert generator devices, means telephone systems or WhatsApp systems or any other say alarm rising equipments are connected to the home gateway. Similarly, home gateway is also connected to the LCD display, through which live monitoring of the system will be seen live monitoring, in the sense so videos are all played live. So this is the scenario. But again, these home devices are again connected to proxy server as well as to the cloud. This is mainly because to allow the people to monitor from outside, in the sense house owner may be residing in abroad, so you want to watch what is happening at this moment, so that you can connect to the gateway, and then you can see what is see the videos live from remote monitoring. For that purpose, remote monitoring purpose, you can, as well as it support, and the cloud is there, no, cloud also supports a lot of storage, so that we all the collected videos, captured videos will be stored in cloud, so that later on, if any issues or anything, we can open the videos and we can monitor the past data. So this is the network. So network, you can see there are four type of devices. There are some cloud data centers, and there are some proxy servers, and there is something called home gateway devices, and as well as smart cameras. All these four type of devices are all having the computation capability. So but this is also a device, LCD display, it will not compute, it just play the videos. Alert generator is again an hardware device, but it is nothing to do with computation. It just generates generated alerts will be notified. So this is the device responsible for notifying, means output devices, AC display, AC alert. These two are the output devices. They just transfer the information to another forum and make the end user to receive. But this camera so smart devices, they have computation capacity. They can do the, means edge device. They can compute locally any, say what, after capturing the videos, they can operate on those videos, like removing the noise from the videos. After removing the noise, detecting the objects and their movements, as well as identifying the threats. That is another model. Similarly, after generating the alerts based on the type of the threat, means it's a fire threat, fire alarm, rising fire alarm. If it is the thief has entered the house, unauthorized entry, then alarm should be raised and sent to the police department. And monitoring from remote should be made possible. For that, it is collected to the cloud, and as well as cloud data center will store the lot of data. So this is the scenario, as well as the hardware infrastructure. Hardware infrastructure is explained in the diagram. As you see, camera is an hardware, home gateway, proxy server, and cloud. There are four layers: cloud layer, edge layer, and then intermediate layer called fog layer. So home gateway and proxy servers comes under fog layer. Cloud is the top layer, and the bottom edge layer is the camera. So this is the IoT infrastructure required for the home security system, smart home security system. But as we discussed, how many models is, we need to design the software for this home security system in modular way. So for deployment on the network, for operation. So we will discuss the models. You can see software models. You can see the diagram which explains the software models. Here, see, sensor means cameras which can captures the videos, live videos, captures the videos. So this is hardware. We items which are represented in like a square bracket, square, are all hardware units. Sensor captures the device, but these elliptic means circular symbol indicates that they are all models, means software model. Model means instructions, set of instructions. So in this project, smart home security system will have four models. So video capture model is a set of instructions used to fine tune the captured videos, removing the noise and fine tuning. So video capture model is responsible for removing the noise, and after the noise is removed, the output of the video capturing model is sent to the threat detecting model. This is again threat detector model is a set of instructions used to identify the objects as well as their movements, and then based on their movement we will also detect the threat. So this threat detector model output is sent to the another model called generate alert model. Here what happens in generate alert model is again a set of instructions which identify the type of the threat. Based on the type of the threat, they will generate the alerts. Means fire alert will go to some other department, maybe thief alert, like that. They identify the alerts category, and based on the alerts type, threat type, alert will be generated. So generated alert is forwarded by this alert AC alert is an actuator output unit. And similarly, after threat detector detects the threat, it needs to be recorded for future use, and that is called store model. So you will see in this application we are having four models. One is video capture model, a set of instruction; threat detector model, a set of instruction; store model is again a set of instruction for storing the videos for future use as well as for remote monitoring; and generate alert model is again a set of instructions to find the type of the threat and then generates the alerts with respect to the threat type. So there are four model. Each four model are the set of instructions. Now the question comes, these are the four software models, and this is the hardware infrastructure. Hardware infrastructure means it will have a sensor, camera. Sensor means a camera, and smart camera, and the gateways as well as proxy server connected to the cloud. This is the hardware infra. Here we need to deploy the software. Our software is having four model as we discussed above diagram. This is the software is having four model. These four model should be deployed on this infrastructure, hardware infrastructure. So you know what is a model. Model means set of instruction needs to be executed. Now which model needs to be executed in which computer? You should see in the diagram there are four types. The camera is a smart computer. It is having execution capacity. It can also execute one or two models. Home gateway is again a fog device. It is having computation capability. It can execute any one or two models because these are the four models. Maybe threat detector model, generate alert model. These are the models can be executed in home gateway. Similarly, cloud data center. It is also having huge computation capability as well as storage capacity. It can do all four models could be executed and stored in the cloud also. So you understood there are the resources: camera, gateway, proxy server, and cloud. These are all the resources for computation. And work. What is the work? Work is means instead of it. So these are the four type of works needs to be done. So now see mapping resource, which resource should execute which model. That is important. No? All models can be placed in camera only, but camera computation capacity is slow, so it takes a lot of time and it delays the system performance. Means quality of service. Quality of service. Any IoT based application, quality of service is very important. So when sensor detect the one sensor captures the video to detect the object motion as well as to detect the threat. If it is taking 2-3 days, no use. If you found that there was a fire at home after 2 days, is there any value for that? No, you have to identify immediately to take the action. So time is crucial. So means depending on the IoT application, quality of service is defined. To meet that quality of service, which model should be put. So home gateway, this is having somewhat little bit more computation capacity, so you can deploy the models here also. And cloud is really having a more computation capacity, but all the captured data should be transferred to the cloud. So network usage, how much time, latency, so understand, so latency is 100, you can see 100 milliseconds, seconds it takes to upload the data, and then execution time after that result should come back. So you understand, so there are issues. So here there are work means models, four type of work means four models, and there are four type of hardware devices. Which model should be placed in which hardware component, so that we will reach quality of service. Quality of service means within less latency, less delay, we need to get the answer, and we must utilize less energy usage, and also we want to use less network units, as well as we need to reduce the cost. We are using the cloud, so if we are using the cloud, you need to pay the cloud expenses, we want to reduce. And more than that, we wanted to use the our fog resources efficiently, because investment is done by the IoT infrastructure owner for all the computing devices. We want to use our devices efficiently instead of using the cloud. Cloud is a third party resource, we need to pay for them. So to put genetic algorithms to map the hardware resources with the software component for execution to reach quality of service. We use genetic algorithms like Wales optimization, particle swarm optimization, many other algorithms. So these algorithms works in such a way that feasible solution means all four model can be placed in gateway, all four model can be placed in cloud, or two models can be in cloud and two models can be in gateway. Like this, multiple and permutation and combinations are possible. These are called feasible solution. All four in cloud is a feasible solution, all four in home gateway, it is feasible solution. Two in cloud, one is in gateway, another one is in camera, means they are scattered in different model in different hardware unit. It is also a feasible solution, means out of all possible feasible solution, we are looking for optimal feasible solution. Optimal means it uses less energy and it response is very quick, and like this. So there are some conditions, means fitness. So based on the fitness, we will decide the best feasible solution called optimal solution. So optimal solution. So for to find this, genetic algorithms are very much useful, and we are applying genetic algorithm to find the optimal solution from the all the feasible solutions. And here how this optimal during finding the optimal solution, how genetic algorithms are finding, and all these details, you could contact BBK Technologies and our WhatsApp number 9353205447, as well as you can write to our email address. So we will help you to implement genetic algorithm to have an optimal solution based on fitness of any of the algorithms. Thank you very much for watching this video. If you are having any doubts for implementing genetic algorithm for getting optimal solution on IoT, please contact us. Thank you very much, sir.